Hi, this is James. I'm an application expert with the Reality Capture Division of IMAGINiT Technologies. As you can see, we're here at AU 2023, and I'm happy to answer some questions for Cadalyst viewers. So reality capture then is the process of capturing existing conditions, either with photos or with laser scanners. We can then take either the point cloud or the model we get from the point cloud and bring it into either Twinmotion or Unreal Engine to then pump up those visualization and get really high quality visualization from existing conditions. Unreal Engine and Twinmotion are both visualization products from Epic Games. The big deal about Twinmotion is that it's fast. So you can take a project from, say, Revit or one of your other Autodesk products and really, really quickly create high-quality visualization within the program. Unreal Engine then is a gaming engine from Epic Games. It's used for high-quality video games as well as TV and movies to give you, again, very high-quality visualization. So the difference then is obviously the speed and the quality that you get out. Twinmotion, very quick, and you get really good quality, but it steps up a level when you get into Unreal Engine. You get much better visualization, much better quality, much more realism. You also get a lot more customization that you can build into your project as well. So a digital factory is really a digital twin of your factory. And to start out the digital factory, we need the existing conditions. So to do that, we can use our reality capture products from Leica, laser scanners, or again, if it fits, we can use photogrammetry to create those existing conditions as the first step then into creating your digital factory. We're seeing construction companies adopt reality capture in many different ways. It could be something as simple as going in and taking existing conditions if they're doing a retrofit. If they're doing new builds, we can go in and scan what's there. So now we have a digital representation of what has been built. Okay, we can take that even further, and once the walls go up, we now have a very accurate digital representation of what's behind the walls. Okay, we can even get into things like verifying floor flatness before concrete's set. So we can use one of the scanners, we can take it out to site, we can scan the concrete floor just after it's been poured while it's still wet, and we can do a floor flatness report on it. Okay, that is very valuable in saving time and money instead of having to break out that concrete altogether.